Welcome to solverfy.
Hello everyone, in this problem we have to calculate total force and moment of force about the point A on the beam AB, which is shown here. Let us see the diagram. This is the beam. This is A point. This is B point. This is the one of the force. This is 3. This is 4. This is 5. So this angle is theta. And the force is, you can call it to be F1, 2.5 kilonewton. This is another point at which this force is acting, which is 1.5 kilonewton, and it is making 30-degree angle with vertical. This is the point B on which 3 kilonewton force is acting. Name it to be F2 force. This is F3 force. This is your y-axis and this is the x-axis. Now we will find components of force F1, F2 and F3. So F1 can be written as, you can resolve this force into two components. This angle theta as shown in the figure. So you can write minus 2.5 sine of theta I cap minus 2.5 cos of theta j cap. Now we will substitute the value of sine of theta. You can see the figure in this triangle. You may measure the sine of theta and cos of theta. Sine of theta would be 4 by 5. Cos of theta will be 3 by 5. So on solving, this F1 force will be, F1 force we will get minus 2 I cap minus 1.5 j cap kilonewton. Now we have to calculate F2 force in component. F2 force, you may see from the figure, it can be resolved in two components. It will be 1.5 sine of 30 I cap minus 1.5 cos of 30 j cap. Substitute the value. 1.5 sine 30 is half minus 1.5 cos 30 root 3 by 2. This is I cap and this is j cap. When you simplify, this force would be 0.75 I cap minus 1.3 j cap newton. Now F3 force is along negative y-axis, so this can be written as minus 3 j cap newton. We have to find the resultant of these forces. So resultant force acting on the beam will be F1 plus F2 plus F3. Now we have to substitute the value. F1 is minus 2 I cap minus 1.5 j cap. F2 force is 0.75 I cap minus 1.3 j cap, and F3 is minus 3 j cap. So resultant force would be minus 1.25 I cap minus 5.8 J cap kilonewton. Now you can draw the diagram for it. This force can be expressed like this: resultant force. This is the resultant force. This angle you can measure. Its magnitude you can obtain minus 1.25 whole square, and this value will be around 5.93 kilonewton, and angle theta you can measure. Direction already I have drawn, so theta will be tan inverse of 5.8 divided by 1.25. This angle is approximately 77.8 degree. Now we have to measure the moment of force. Moment of force about the point A, due to all forces we are measuring. So it will be the point at which F1 force is acting. We can mark as a P point. See the figure. We are marking this point to be P and this point to be Q. Is it clear? Now follow the diagram, and we are writing here AP cross F1 is the moment of force at A due to F1. AQ cross F2 plus AV cross F3. Now from the figure you can see AP vector is 2i cap cross F1 we have minus 2i cap minus 1.5 j cap. AQ is 4i cap cross F2 vector 0.75 I cap minus 1.3 j cap plus AB vector. AB vector is 8. See the figure, you will find this value will be 8. So 8 I cap cross minus 2j cap. When you simplify it, you will get, if you simplify it, you will get minus 3k cap minus 5.2 k cap minus 24. I have to do the correction here. The force is 3 Newton. So I am making the correction here. This is 3. So minus 24 k cap. So this will be around, when you simplify it, this will be around 34.8, or you may write unit is kilonewton meter, or this could be written as 34.8 kilonewton in clockwise direction.